thank you for joining today's session. I represent Visionet. Today, I'm excited to share our journey with you, a journey that began in 2019 when we embarked on integrating and evolving digital twin technology with railway assets. We are a startup. We started in Ukraine, Kiev. And now our assets that we have been utilizing digital twins deployed across countries, Egypt, Bolivia, Turkey, Ukraine, Poland, and Korea. I titled today's talk Beyond Simulation because despite the popularity of digital twins, as Jonathan mentioned, their depth, the utility are often not fully understood or realized. So in this presentation, I will cover our initial motivations for adopting digital twins, the challenges we faced, and invaluable lessons we have learned along the way, and our failures. Of course, that's the most important part because most of the times people pass that part because it is the part you will understand what you will be working and having efficiency. So I will delve into how we transform digital twins into proactive and intelligent components of our operations, working in tandem with our asset management system and engineering teams. Finally, I will discuss these technological investments, how have played an important role in promoting sustainable practices and advancing in circular economy, particularly through extending life cycle of our existing assets. So let's dive in. What are some of the challenges we face when managing our operations? I'm sure we all have similar answers. The obvious one is communication with our trains. Trains are our most valuable assets, yet once they are out on the tracks, it is often feel like they are off the grid. We might find ourselves relying solely on driver feedback, or worse, customer complaints to gauge how things are going. Imagine this. Once train leaves the station, we receive little to no updates on crucial systems. How is the air conditioning holding up? Are the doors functioning correctly? Sometimes we don't hear back even from the drivers themselves. And let's not forget, some of our trains do not return for scheduled maintenance for months. I know some of you might be thinking, well, we don't even get any data from our trains. Well, many companies actually receive data. They are not even aware of it. Sometimes through different systems like trains, operation, and maintenance, it's often overwhelming because most of the companies use many different systems. And some companies that we have seen even use 5, some even use 10. Without a systematic way to collect and integrate this data, we end up flood of numbers and statistics. So what happens then? We are buried under the data, yet without any organized, actionable information. Actually, we have none at all. It is kind of mission impossible trying to make sense of an avalanche of details with no clear starting point. When I mention managing all assets, what exactly do I mean? Well, let me ask you a question. How do I connect train with engineers? Or how can I connect supply chain with trains? Often we find ourselves juggling multiple systems to manage different assets without any connection. But here is the catch. Despite all these systems, they are still essentially operating blind. Why? Because unless these systems are interconnected, all that data isn't just giving us full picture. It is like trying to see with the lights turned off. So without connecting all these assets, we simply can't see the whole story. So when we embarked on this journey, as I said, in 2019, we were certain that a digital twin will be our magic touch. We dreamed of creating a software that will gather all the train data and display it seamlessly to our operations and maintenance teams, as in this video. And we would see failures pop up on the screens, quickly solve problems. We expected clear, useful data like enjoying perfect blue sky. But reality hit us like a pie in the face, like in the movies. Instead of blue skies, we faced a stormy weather forecast. The trains we were dealing with sent back between 6,000 to 12,000 data per second. I want to repeat this part again. 6,000 to 12,000 data per second from the trains. Trying to monitor all that data in real time through a digital twin felt like we needed an army of people watching it nonstop. Let's not even start on the reliability of data from the technology that's old enough to tell a story, because I told you that some of the assets are more than 10 years, some of them are more than 30 years. Here is the kicker. We eventually learned that even the data from some big name manufacturers had about as much reliability as a weather forecast, like promising a slight chance of rain when it is already raining a lot. So we quickly discovered after this magnificent failure, relying solely on digital twin was like trying to solve a jigsaw puzzle with only half the pieces. Keeping our team glued to their screens around the clock, no, that was no go. It was impossible. We needed a smarter solution, something that kept the magic alive without turning into a never-ending screen watching marathon. So we shifted gears to a more proactive and intelligent model, one that could seamlessly integrate and make informed decisions. Instead of diving into artificial intelligence, we opted for more ground approach. We leveraged simple yet effective way to start. Like Jonathan mentioned, starting small. So we developed our first mobile app application for asset management system in 2021. We used algorithms derived from our real-world experience to piece together data and the system-based automated work orders, utilize condition monitoring with more reliable data, and created our smart CCTV system to monitor infrastructure for seeing the outside impact. So once we connect all, it sounds easy, but not, we reach our intelligent digital twins. Last 2 years, we have been working on this, and I am excited to show what we achieved. And let's just stay with me. I will try to explain you more with videos and pictures with digital twin itself for you to better understand. So how do we gather, develop, and synthesize all this data? We opted to split our focus into two main categories: digital train and digital depot. As each has its unique dynamics, let's first dive into the first category, into digital train. To make our digital twin truly effective, strong main monitoring, condition monitoring is crucial. We start first by collecting the data and mirroring into the cloud. This data is then integrated into our virtual model, enabling us to conduct real-time monitoring remotely via our mobile and web-based platforms. So we simply actually connect our hardware into the train's car computer, and then use a SIM card to transmit the data. So then you'll be able to see such example that I'm trying to show you here. It is hard to believe, but most of the trains that we have seen until now have got a core computer and data capabilities. For example, we recently worked on 1972 diesel locomotive in Bolivia. Yes, 1972. It is older than me. Surprisingly, it had a car computer filled with data that even operating company wasn't aware of it. Primarily because they lack this system display data locomotives. I'm sure most of the people are here, aware of the trains, and when most of the trains have train monitoring systems or human machine interfaces. But in this train, it was lacking, so that they weren't aware that there's a data that they can see. Here is a snapshot that I was trying to explain you. This is latest projects in Seoul, Korea. And this train is driverless, and relying entirely on signalization. We kicked off this project 2 months ago. We have equipped it with advanced health status and index page in the digital twin to ensure detailed condition monitoring. This is like on the bottom, you're seeing the train's digital twin itself. The data is about the temperature and the other things that we have been talking about. So our systems monitors each train continuously around the clock, 7 days a week. In the video you are seeing now, we are showcasing one of our projects in Ukraine involving high-speed trains. So in this particular project, we monitor 12 trains. Each train transmits data at a rate of 6,000 per second, including updates on the data includes about the train status, location, failure information, and the information that we also created, like alarms, notifications, map-based visualizations, make it straightforward to monitor, assess the health of each train. So the digital twin that we have been talking about. So in this screenshot from our mobile app, you can see the digital twins of the train. The display gives a detailed overview of various parameters such as doors, pantograph, toilet, restroom, electric components, mileage, both inside and outside temperature. In this video, for example, we are seeing that if you notice the adjustment, the train makes exit approach to station, changes its speed, doors opening and closing, and the pantograph lowering. This is the web version of the digital twin systems that you have seen in the mobile. It is showing the same data on the same train. Both the mobile and the web options, we offer the same functionalities. The only difference is the screen size. Whether you are on your mobile or you're at your desk, you have complete access to all the features, and you can monitor. And showing here, as I try to show you maybe a little, if some people connected with their mobile so that they can see clearly how digital twin is seen on our desktop version. So this is one of the train in Ukraine project. It approaches the station, and once it approaches, it opens the door. You might realize maybe the doors from gray to turn into blue, and then the pantograph is going to be lowered now. Yes, pantograph is lowered, and the speed is zero. You can see that some part here like red, orange, yellow, and some other notifications. I will explain them detail later. So notifications from the system. We provide detailed notifications about each train status, as I told. This includes information on failures, general train conditions, pinpointing exactly what happened, when, where, as well as the frequency of each failure or incident. Based on our extensive experience, we have also implemented additional alarms, such as smoke alarms and emergency brake alerts, passenger area temperature reductions, etc. For example, we have encountered situations where drivers are smoking, sleeping, or eating in the cabins. And in one of our funny experiences that when the drivers were smoking, because they have the screen, they get only the smoke alarm by themselves. And when they get the smoke alarm, they just press the button because they are smoking. They're just ignoring this smoke so that no one is aware of it. But with our systems that integrated, we have this experience, and then the engineers called the driver and saying that we received a smoke alarm. But they were saying that there's no smoke because they were just trying to cover their smoking in the cabin. Additionally, we have an alarm for the emergency brake. This is actually one of the very important things that we have seen with high-speed trains that they are operating also of the cities. If a train applies an emergency brake, remains stationary, let's say for more than 5 minutes, in a location where there is no station, an alarm is triggered. So this alarm sent directly to the engineering team and operation team. Or I'll give you another example. This is very deep engineering that I can explain to you, is that when train hits an obstacle, we realized actually when train hits an obstacle, some of the bogies have different behavior in speed reduction. So if we create this alarm in the system that, for example, if the speed reduces from 100 to 99, 98, 97, rather than 100 to 75 directly, then the system creates automatic work order and the alarm to the engineering team. And we did not use AI on this. It's just a simple experience. And I will try to explain this more in the next coming parts. So you have received the data and you have all the information. What is next, right? And what I'm gonna do. The proactive action part is what happens next when we receive a notification or alarm. If the relevant personnel app as an engineer, for example, is closed, our system doesn't stop there because we created SMS or Telegram messages. Telegram is kind of WhatsApp application. It is a messaging app to ensure the alert is received by the engineer. This process is closely tied up to what I discussed in the previous slide. It is all driven by the trained data and the custom algorithms that we have developed. So we continuously record all the data for what? What purpose, right? So we all this data allowing us to discern patterns, locations, and the frequency of failures for comparison. Additionally, our unit monitoring system, as you see in this video, lets us dive deeper into the trained data over time. It is like a similar like you having a recorded video. We can fast forward or rewind through the time to observe any failures, see how related systems react when failure detection happens. This capability provides us with profound insights, enabling deeper engineering analysis of any failures and or incident happens. So one of the important things is that automated work orders. This system automatically generates work orders that I've been explaining, serving as the cornerstone of actually condition-based maintenance system. I'm sure most of you heard about the CBM. So I will also try to explain how the CBM is developed on our side. This capability transforms our digital twin from a passive observer into an active participant in our operations. It is a crucial development because it brings intelligence to the forefront, fundamentally changing how we manage maintenance. So our algorithms use straightforward logical rules to assess various scenarios, including the type and the quantity of failures and the specific conditions under which these failures occur. Let me illustrate with a simple example. Consider the doors in the train. Some projects have hundreds of doors. And if there is any problem on the door, for example, or if you need to check the doors in periodical maintenance, it takes hours and hours to check and understand whether they are operating correctly. In this project, for example, that I've been showing in a couple of projects, for example, in Egypt and Ukraine, we have seen that if any doors opens more than it is from standard operation, let's say 6 seconds, its normal standard operation is 5 seconds, then automated work order is generated and then send it to an engineer. The engineer then delegates the repair task to a technician. In urgent situations, I'm sure that some of you ask these questions in your mind, then if there is is posing an operation or safety risk, the system takes swift action. By the system, I mean that people together with the system itself, with an engineer, by removing the affected train from the service, or if this happened, I mean this alarm or information that we received in remote areas, let's say 500 kilometers away from the city, on top of a mountain, somewhere that is very far away, then this issue is critical. Then the driver is called, quickly contacted, and to implement preliminary safety measures until the service ends. And we had many experience and examples with this kind of issues. In this example, like I would like to show you a little bit, in detail. You can see this automated work order when it comes. You can see the date. This is, for example, from yesterday. It shows event happened how many times. You see that 51 times between which hours. This is important because sometimes some failures happens like hundreds of times when the train is in an operation. So this is actually one of our latest development. I'm sure most of you have heard about ChatGPT. You heard about Google AI, and most of you are curious how can we implement this in railway? So this is our Vispo chatbot that we use in, like, how we are using is that we upload all our operational training menus, part catalogs, even technical drawings, all stored securely in our cloud. Whenever an engineer encounters a query or question during the work, they don't need to flip through bulky menus because you have the menus like thousands of pages and you need to know how to look, where to look, right? Instead, they can simply chat with Vispo, like while they are working. Remember the door example that I was talking about? So this is the questions about the door example. So then engineers can ask the Vispo to double check those details. For example, asking like in this question that you can see about the safety part. And then when the Vispo responds, it shows the reference, the answer it takes, and shows the menus directly going to the page. It shows the answer, as you've seen. What is more is Vispo is multi-language. We are using the multi-language. For example, this manual is English. We have Polish in Poland or Korean in Korea. So you can ask in Korean. If the manual is in Korean, the answer comes in Korean. So, as you see in this video that, for example, is asking while you are, let's say you are working and then you need to know door opening and closing time, right? Because you are testing something or you receive the automated work order that you want to know the answer. When you ask this, let's see the answer together. So it gives the answer that, you know, standard opening and closing time for this system in this train 5 plus 1 minus 1 plus minus 1 second. It shows the references of the documents giving this information. You can press and then it directly shows where this answer is coming from, because there are different doors, right? Like you have passenger access doors, you have a partition door, you have a trap door and other doors in the system, so that it shows all related ones. So once we establish robust condition monitoring, the next step is to take proactive action, right? Every action that we take is driven by live notifications, insight from condition monitoring, and our accumulated experience, like all culminating in auto work orders. I was explaining that the auto work orders in previous section about taking an action, right? This approach, what we call is condition-based maintenance, or CBM for short. Let me draw your attention to this graphic here. So traditionally, every piece of equipment on a train has a set of maintenance schedule, like based on mileage or based on time. As we gather more data, we start to see how external factors like infrastructure impact the reliability of lifespan of each part. And this data tells us the true lifespan each component, right? So in this graphic, we're seeing the normal lifetime, early lifetime, and end of the lifetime. So what is the condition effective zones for each and every equipment? And if you think about on the large scale, the train itself, right? For like, let's say 15,000 mileage or 30,000 mileage or even a million kilometer heavy general maintenance. So what is the answer of the question when the end of life starts or when it ends? So from our findings, we can begin to adjust the maintenance schedule for each unit. This not only extends the life of both minor and major equipment, but allows us to tailor maintenance periods based on real conditions, not just set intervals, not fixed intervals. Because usually when you have the train, like 20 years of train, you have, and you still use the same manual. We have seen many companies, they are doing the same. So this is like, what is, if you ask me what is condition-based maintenance, this, as you can see, that scheduled maintenance, you can extend from too early to on time. Because we know from those experiences with the intelligent digital twin and then all those data that we received, we can extend without compromising the safety. I will explain more about this in the next coming part. This part of the development cycle, as I have explained, the condition monitoring, proactive action. Once you do develop these two parts, then you are ready to go in this cycle to rescheduling your preventive maintenance. A crucial aspect of our digital train is monitoring the infrastructure, as I explained, that impacts both train operations and performance. Now, the million-dollar question is, how can we enhance passenger comfort and operational safety while also extending component lifespan through condition-based maintenance, like I asked in the previous slide? The answer isn't complete without including smart CCTV systems in our strategy. We have discovered that achieving truly intelligent digital twins isn't feasible without these advanced monitoring tools. Let me show you what I mean by with a couple of video clips, because I will try to zoom in for you better understandings. In the first video, our visual AI system here, this is the pantograph, identifies that the panto is damaged. See here. So this is actually the door opening the prediction. Damaged pantograph, you continue on your operation and you break it. So what are the other parts of this, the smart monitoring system? What we need for? For example, here you see the drivers. There's a driver cabin. You can see how many persons in the cabin. You can see any intrusion. If there are 3 people, you will see it. If they are playing with their mobile, you can see it. Because as I have told you, like they can smoke, they can eat. We have seen people are sleeping there. Believe me. Some people are leaving the cabin. It is because they are close to their home. And this happened in some countries. And in one accident that we know of, many people died. This is the part you can watch and monitor your infrastructure. And here you see that which way the train is operating is using. And also, finally, you can also see that the window is broken. I'll go a little quickly because I talked so much. I'm sorry to some other parts, like for passenger counting, and you can also go for passenger safety related matters. And to get your attention to TV monitor and refrigerator rather than the people. As I mentioned earlier when introducing what digital twin is, we decided to, intelligent digital twin is, we decided to focus on 2 main aspects, digital trains and digital depots. We have already dived into how digital trains operate and various categories they encompass. Now let's shift our focus and talk about other crucial part of our system, the digital depot. If you recall, I posed a question earlier, how do we effectively connect engineers with trains? The answer lies in implementing a comprehensive digital personnel management system, because human is the part doing the real work. This system must be seamlessly integrated with our maintenance management and supply chain to allow complete oversight. That we can track every work performance of each personnel member and monitor the number of parts they have installed or removed from the trains, while we can see their working hours, their shifts, etc. I will try to a little bit, if you're looking at your mobile. So this is our web-based systems. It's about digital management, personnel management. So you can see the shifts, you can see the whole organization chart. And you can see that because some companies have different locations. I'll quickly go over to the next page because we have time limitations. Digital warehouse. Think of a train as a complex Lego set built from numerous spare parts. It is crucial for us to monitor how each part performs, and we need to track its health and reliability. So why do I emphasize the importance of connecting all assets, engineering teams, trains, and parts? Because when everything is interconnected, we gain the ability to track the mileage and performance of each part with precision. For instance, we don't need a sensor on every window to track its mileage. We know who installed it, right? From the work orders, it's the maintenance management step, at what mileage, when, where. So then system automatically calculates because of the mileage information that it's received from the train. Then we know the mileage of the window when it is removed. So this is just very simple. When you put things together and connect together, then you receive so much information than you're actually looking for. So the smart maintenance is the main element of the digital depots because our core has been the condition-based maintenance. This approach enhances operational efficiency, safety, and reliability by leveraging advanced technologies to monitor and manage every component and asset. Intelligent, interconnected, and highly efficient system. So maybe saying is easy, but if you connect all those, like the smart maintenance system is the core that you need for intelligent digital twin. And then intelligent digital twin, so digital twin to become intelligent, you need smart maintenance management. So digital twins plays a crucial role in advancing the circular economy, right? By allowing the condition-based maintenance. This system ensures that parts are only replaced or maintenance based on the actual need rather than the fixed schedule. This not only extends the lifespan of components, but also significantly reduces waste and inefficiency. Intelligent monitoring, the integration of intelligent monitoring tools like smart CCTV and advanced diagnostic help in identifying potential issues before they become critical. This proactive approach reduces downtime and resources waste, ensuring that trains operate more efficiently and sustainably. Infrastructure analysis, monitoring the infrastructure that affects the train operation is vital. Understanding how infrastructure impacts the reliability and life cycle of train components helps in making informed maintenance decisions. I want to repeat this again, informed maintenance decisions that contribute sustainability by optimizing resource use and minimizing unnecessary replacements. Because many of our clients that we have seen, many of our places that we have been worked, we're seeing this unnecessary replacement over and over again. Resource optimization, by collecting detailed data on performance and wear of various components, the system can predict their end of life more accurately. Remember that I was talking in condition-based maintenance about the life cycle. This leads to better inventory management and procurement strategies, reducing overstocking and underuse of resources, which are key principles in the circular economy. I will not go more into this, and I will go quickly over it. In summary, by leveraging the digital twins, especially intelligent digital twins, smart monitoring, and data-driven maintenance strategies, railway system can significantly advance circular economy practices and enhance sustainability. These innovations ensure that resources are used efficiently, waste is minimized, and the environmental impact of railway operations is reduced. So this is my last slide. So what kind of performance we receive, right? If we do this intelligent digital twin. Here's the result from one of our projects that we have been using intelligent digital twins and digital twins itself for 4 years. For 2 years, we used digital twin, and then we applied the intelligent digital twin with informed decisions that I mentioned earlier. I don't want to bore you with many results, but only one as you see in this table. When you look at the table, you can see that these different types of engineering and inspections are reduced by using these intelligent digital twin systems. In some cases, we saved 50% by changing the interval from 10,000 to 20,000 kilometers. And this is all thanks to condition-based maintenance and all the smart maintenance systems and intelligent digital twins that I've been talking about.